Hello everyone. Last time we have completed line integration. In line integration, we have totally learned three types. First one is simple line integration. Secondly, the line integration depending on a path. And thirdly, the line integration do not depending on a path. And basically we have obtained that line integration gives the work done by a particle moving along the curve. Today we are going to start the Green's theorem. Green's theorem is a relation between double integration and the line integration. Now the statement is, let R be a closed bounded region in xy plane whose boundary C is consist of smooth curves. That means R is any closed region whose boundary C is a smooth curve arc, and let f bar is equal to f1 of xy into I plus f2 of xy into j be a continuous function, and f1 f2 have a continuous partial derivatives everywhere in a domain R. Then the double integration del f2 by del x minus del f1 by del y dx dy is same as close integration f dot dr, that is close integration f1 dx plus f2 dy. Now here the line integration C is taken anti-clockwise, taken in an anti-clockwise direction. That means we are taking in a opposite direction of clock. Before going on to this, we are going to check one figure. Suppose this one is your closed curve. Boundary is C, and the bounded region, this gray color region, is R. Then if you are going to find the double integration over this region, then this double integration is same as the line integral over the curve C, which is nothing but the boundary of this region. Okay, so this is the theorem says. Now there are two types of examples. First one is a verify, second one is a using Green's theorem evaluate something. So first we are going to check the example of verify. Now see, verify the Green's theorem in the plane for integration 3x square minus 8y square dx plus 4y minus 6xy dy, and the path is bounded by regions y square is equal to x and x square is equal to y. See, here you have given a line integration. So whatever the term with dx, that is f1, that means f1 is equal to 3x square minus 8y square. Whatever the term with dy, that is f2, that is 4y minus 6xy. Here we have a two path, y square x and x square y. So they are our curve C. So we are starting with the figure. First we have drawn the figure. X square is equal to y and y square is equal to x. X square is equal to y is a parabola along y axis, positive y axis. Same manner, y square is equal to x is a parabola along positive x axis. So this type of figure we have. So this is x square is equal to y, this is y square is equal to x. Now you have to find out these two intersection point. For that we are going to solve these two curves. What I have done is I am going to substitute the value of y here. So y is equal to x square. So x square the whole square, that is x raised to 4 is equal to x. So you have x raised to 4 minus x is equal to 0. Now common out x, that will give x into x cube minus 1 is equal to 0. So from this, here you have two factors, x cube minus 1 also has two factors, x minus 1, x square plus x plus 1. So you have x is equal to 0, x is equal to 1. And from the third factor, x square plus x plus 1, you have a complex factors, which is not required as we are going in a xy plane. So x and y are reals. So x is 0, then y is 0. And x is 1, then y is 1. So we are going to put it here or here and in any one of them. That means you have two intersection points. First one is 0, 0 and second one is 1, 1. That means you have these two intersection points for the curves. So you have two curves C1 and C2. Secondly, whenever we are going to take line integration, then we are going to take it in an anti-clockwise direction. So first we are going along C1 and then we are going to return along C2, because whatever the origin point, that means we are starting with whatever the point, we have to reach on that point as we are taking a closed integration. Now the first thing, we are going to find the left hand side of Green's theorem. So f1 is equal to 3x square minus 8y square and f2 is equal to 4y minus 6xy. So del f1 by del y is minus 16y and del f2 by del x is minus 6y. And therefore your double integration del f2 by del x minus del f1 by del y dx dy is equal to, now del f2 by del x is minus 6y minus del f1 by del y is minus 16 dx dy. So basically simplifying this one, we have 10y dx dy. Now the limit of region, that means the region bounded by these two curves. So as we have done in a double integration, we have to draw one strip parallel to x or parallel to y. So I am starting with strip parallel to y. Okay, so limit of y is starting from lower curve x square and ending to upper curve y is equal to under root of x. So a limit of y is x square to root x, and limit of x, the minimum value of x in the region is 0 and maximum value of x is in the region is 1. That means this strip is moving from minimum 0 to 1. So limit of x will be 0 to 1. Now we are going to integrate it. So first integration is with respect to y. So y has integration y square by 2. Putting the limits, so root x square, that will be a x, and x square the whole square, that will be x raised to 4. Simplifying this one, that will again integrating, that will give you 5x square by 2 minus x raised to 5. And limit is from 0 to 1. First put limit 1, then put 0, that will give you 5 by 2 minus 1. That means answer is 3 by 2. This is our left hand side. Now for right hand side, you have to take a integration along the curve y is equal to x square. Y is equal to x square, that means dy is equal to 2x dx. If you are going to put this value in your line integration, then instead of y you are putting x square. So that will give you y square is equal to x raised to 4. Y is equal to x square. Y is equal to x square, that means 6x into y, that will be a 6x cube, and dy is equal to 2x dx. Dx common out and multiplying this 2x inside, that will give you 3x square minus 8x raised to 4 plus 8x cube minus 12x raised to 4 dx. Now simplifying, that will x terms of x raised to 4 minus 8 minus 12, that is minus 20x raised to 4. Integrating, so x square has an integration x cube by 3, x raised to 3 has an integration x raised to 4 by 4, and x raised to 4 has an integration x raised to 5 by 5. So we have x cube plus 2x raised to 4 minus 4x raised to 5, and limit is from 0 to 1. Now first putting the upper limit, that will give you 1 plus 2 minus 4. That means 1 plus 2 minus 4 has an answer minus 1. Now we are going to take the integration along C2. For C2, the curve is x is equal to y square, and that will give you dx is equal to 2y dy. So if you are going to put these values in a integration, then integration along C2, 3x square minus 8y square dx plus 4y minus 6xy dy. Here you have x is equal to y square, so y square the whole square, that is y raised to 4. Dx is equal to 2y dy. X is equal to y square, and that's why we have the 3y raised to 4 minus 8y square into 2y dy plus 4y minus 6y cube dy. Now limit is from 1 to 0. See, since you have reduced it in the form of y, so the limit of y. So limit of y, we have taken integration from point 1 to 0 0. That's why the y varies from 1 to 0. Okay. So we are going to write the limits according to direction. That is very important. Now simplifying, that means dy common out, 2y multiplying inside, that will give you 6y raised to 5 minus 16y cube plus 4y minus 6y cube. Y cube we are going to combine out, so that will give you 6y raised to 5 minus 22y cube plus 4y into dy. Integrating, that will give you 6y raised to 5 y raised to 6 by 6, so 6 will be cancelled out, and we have y raised to 6 minus y raised to 4 by 4, so 2 will be cancelled out, and we will have minus 11 by 2 y raised to 4 plus y square by 2, so we have 2y square, and limit is from 1 to 0. First we are going to put 0, then all terms will be 0, minus we are going to put 1, so 1 minus 11 by 2 plus 2, and that will be basically 11 by 2 minus 3, so answer is 5 by 2. Now for right hand side, integration f dot dr is equal to integration c1 f dot dr plus integration c2 f dot dr, that is minus 1 plus 5 by 2 is 3 by 2. So from result 1 and 2 we have a both same result. So first one is also 3 by 2, right hand side double integration is also 3 by 2, and same manner the line integration is also 3 by 2 and therefore from 1 and 2 the Green's theorem is verified. Now this is the verification, but instead of verification, suppose you have only given using Green's theorem evaluate the line integration this along the closed curve formed by y is equal to 0, x is equal to 1 and y is equal to x. So here what you have, f1 is equal to xy minus x square, whatever the term with dx, that is f1, whatever the term with dy, that is f2, that is x square y. Now derivative of f1 with respect to y, that is x, derivative of f2 with respect to x is 2xy. Now the curve C is bounded by line y is equal to 0, that is x-axis, x is equal to 1 is a vertical line, and y is equal to x is a line having angle 45. So we have this closed curve bounded by these three straight lines. Now we are going to use the Green's theorem. So for that we have to write down the limits. So first I am drawing the strip of y. So y is varying from y is equal to 0 to y is equal to x, and then minimum, this strip moving from minimum value of x is equal to 0 to maximum value of x is equal to 1. That means x varies from 0 to 1. So by Green's theorem, close f1 dx, closed line integration f1 dx plus f2 dy is equal to double integration del f2 by del x minus del f1 by del y dx dy. Correct? So f1 and f2 we are going to, that means close integration xy minus x square dx plus x square y is equal to double integration 2xy, del f2 by del x is 2xy minus del f1 by del y is x dx dy. Now the limits of R we have already written. First one is from 0 to x, second one is from 0 to 1. So 0 to x 0 to x and 0 to 1. So first integration is with respect to y. So y is the integration y square by 2, and that will give you xy square minus x integration of x with respect to y, that is x into y. First put the upper limit x, we are going to put x, then you have x cube minus x square, and if you are going to put lower limit 0, then both terms will be 0. Now integration of x cube minus x square, that will be x raised to 4 by 4 minus x raised to 3 by 3. Limit is from 0 to 1. So if you are first going to put the upper limit, that is 1 by 4 minus 1 by 3, minus lower limit will be 0. So simplifying this one, that will give you minus 1 by 12. So see, here we have directly used the Green's theorem. We are not verifying it. What you have asked is simply evaluate this line integration using Green's theorem. So instead of line integration, which will be a very long process because we have to find out 3 integration along curve C1, along curve C2 and along curve C3. That means first y is equal to 0, x equal to 1 and then y is equal to x. Instead of that, we have directly taken a double integration, and that will give you the required answer. And the answer will be minus 1 by 12. Okay.